Hey guys, this is going to be the quick and dirty Unit 5 review, where we just kind of talk about each of the pieces of Unit 5, how they fit together, and solve a couple problems that are in the PDF review. Again, I'm not going to work through all of the examples in that, so just look through my work and see if you have questions and ask away. But let's get started. The first thing I wanted to talk about is the fact that this test is designed to be done without a calculator. So you're not going to see a lot of the word problems, and you're also not going to need to find angle values. You'll be able to use the picture in order to find expressions that would find an angle value, but you technically don't even need a calculator on this test. So and then I think there was something else, but we'll see. I'll get there in a second. So the first thing we learned this unit was special right triangles. There will not be any explicit questions regarding special right triangles, but remember, you have to know the ratios in order to make your reference angles and find your exact values. So this is the 45, 45, 90 right triangle. Again, we did this little chart thing if it helps you out to know that it's going to be x, x, x root 2. And when we're thinking about our unit circle and our triangles that we're trying to find the exact values of, we're actually going to just go ahead and make all those x's the simplest number we can, which is 1. So when you're thinking about the ratios on the sides of your right triangles, you're just going to use 1, 1, root 2 for a 45, 45, 90. Okay, a 30, 60, 90 has slightly trickier values in it. Across from your 30 degree is going to be your x. Across from your 60 degree is going to be your x root 3. And then your hypotenuse across from your 90 is going to be 2x. And again, for the purposes of finding these values, we're going to use the simplest number we know, so 1 for x. So the values on your right triangles will be 1, root 3, and 2. Root 3 is a little bit in between 1 and 2. It's like 1 point something. So that's the middle side, and that's where it's going to head. I always label my smallest side, then my biggest, and then I just put the one in between. Okay, so again, there's not going to be any explicit questions about special right triangles, but you have to know these ratios by heart in order to find exact values. Same thing with the trigonometry review video. 5.2 was really important because it introduced us to cosecant, secant, and cotangent. However, you may not just need to, find a tangent of an angle or whatever. We'll use it in regards to an exact value. So remember, if you're ever looking at your SOHCAHTOA, that all that means is that the sine of an angle is equal to the opposite leg over the hypotenuse. And remember, when you're dealing with a reference angle, it's always going to be formed with the x-axis. So the side that's opposite is going to end up being your y value, and the side that's adjacent to your theta or your reference angle is going to be your adjacent or your x value. Okay, and obviously this one's your hypotenuse. You can always use the Pythagorean theorem to solve. And remember, a lot of the MyMathLab assignments required you to rationalize the denominator, but that's not required. Okay, the MyMathLab software is different than like when we go through and we can grade it and look at it and be like, oh yes, those are the same two things. So again, this is SOHCAHTOA back from geometry, and then we learned about cosecant, and cosecant is the reciprocal, the flip of sine. So instead of being opposite over hypotenuse, it's hypotenuse over opposite. Secant is the reciprocal of cosine, so it uses the adjacent and the hypotenuse. And then cotangent is the reciprocal of tangent. Remember, they're not inverses of one another, but they are reciprocals. And then again, in 5.3, we did solving right triangles, and we did those kind of crazy word problems. There aren't any word problems on the test. The way that they would test some of these applications would be to look at a picture and determine which statement is actually true, which is almost like one of the trigonometry review things, where in this particular problem, they gave you that this was your angle, and they wanted to know which statement was true. This was, you can't really see, it's really small, A, B, and C. And so all I did here is there was sine, tangent, and then cosine. So I wrote those values out and then manipulated the equation. So like, for instance, sine of theta is equal to the opposite over the hypotenuse, so A over C. And then in this first equation, they multiplied through. But remember, sine didn't have anything to do with the adjacent leg, so I could cross it out. And so that was kind of the problem-solving strategy there. So you'll need to know about how to label a triangle as far as adjacent, opposite, hypotenuse, but you're not going to have to go through and solve it out and find the missing sides or the missing angles. Okay, so let's get into the meaty part. So we talked about the angle measure in 5.4. And this is one where we talked more about the vocabulary, and we kept things in degrees to kind of remember, review, keep that kind of, stable in our brain. So whenever you have an angle, remember you always start with your initial side on the positive x-axis. This is always where your angle is going to begin. And when they ask where an angle terminates or where the terminal side is, that just means where the other side of the angle is. So you could have a terminal side, for instance, here in quadrant 3, and then we draw our little arrow around to say this is the direction that I went. Remember that when that angle measure, you have an infinite number of coterminal angles to a given angle, because instead of going around counterclockwise, I could have gone around clockwise and gotten to that same spot. I could have also rotated a bunch of times and gotten to the same spot. So there is an infinite number of ways to write one angle. So that's when they ask you for coterminal, they're probably going to ask you between a certain value. Okay. The other thing to note is when you have this this is always going to be your 0-degree angle right here. And then directly across will be 180 degrees or pi. And so then halfway in between would be your 90 and your 270. Okay, that's if you have a positive. That's going around counterclockwise like we normally do. But if you were to go backwards, you just reflect those. If you were to go a negative angle, you just go underneath instead. So again, this gives you the definition of coterminal. It's just angles that end in the same place. And the easiest way to find that, it says or, it's fine, is to either add or subtract 360 degrees. So when they say find a positive coterminal angle or a negative coterminal angle, that's just telling you what direction should I go. So for this first one, in order to find a positive coterminal angle, I could just add 360 degrees and that would get me to a positive value. And same deal on the second one. However, if I wanted to find a negative for 470, if I subtracted 360, that's not going to give me a negative value. I'd have to subtract 360 again to get the negative value. So again, there are a lot of correct answers for these. A lot of times they'll tell you we want the angles between 0 and 360 or whatever. But all you do to find coterminal is add or subtract a rotation, so a whole 360 degrees. In order to find a reference angle, remember we need those reference angles to draw our exact values and to find those triangles. So reference angles are always acute angles, so they're always less than 90. They are always a positive angle, so you'll never have a negative reference angle, and you're always formed with the x-axis. So you always are either going to drop your angle down, you're going to put that vertical line down to the x-axis, or you'll draw it up to the x-axis. And it kind of makes that little bow tie if you were to draw it in there. So your reference angles will always fall on that bow tie. So if you look here, if I was finding the reference angle for 580, I would first graph my angle. It terminates in quadrant 3. It's bigger than 360, so I had to make a separate rotation. So this is also 540 over here. It falls in between those two. So my angle is 580 degrees. The reference angle, again, I'm going to draw it up to the x-axis. And it's this angle right here is your reference angle, the one that's formed with the origin. So all you have to do is ask yourself, how far away is my angle from the nearest x-axis point? So from 580 to 540 was 40 degrees. Again, it has to be a positive value. So for instance, if I look here, I know I'm looking at what's the distance between negative 264 and negative 180, but it's the positive distance. It's a distance. It's how far away is it? So between negative 264 and negative 180, there's 84 degrees. So it's very close to the y-axis, but we're still going to always draw it to the x-axis. So that's how you find a reference angle. Oops. Now let's talk about radians, our favorite. Remember, a radian is just another way to measure an angle. It's like being able to measure a distance in inches and being able to measure that same distance in centimeters. A radian is just another way to measure an angle. We use it because it's in terms of a circle. So with our unit circle, it makes life a little bit easier to talk about breaking it down into those little chunks that are actually divisible. But a radian, again, measures an angle. So if I wanted to find a coterminal angle, I can still apply the same definition I did before. It's just now I'm just going to be adding or subtracting 2 pi. One whole rotation is 2 pi. So if I looked on my coordinate plane, I probably shouldn't use orange on this. If I look on my coordinate plane, I go from 0 And then this one, instead of being 180, it's pi. And then a whole nother rotation is 2 pi. Okay. And so that means in between in here, these are always going to be, the 90s are going to be pi over 2s. So whenever you're orienting yourself on your coordinate plane, there you go. So if you wanted to find coterminal angles, again, you're just adding that one rotation. So if I wanted to find a positive coterminal angle, you'll likely be adding 2 pi. If I want to find a negative, then I'll subtract. And again, you have to find that common denominator before you start. So because this one has a 7 underneath, I'm going to have to double that and put it up in the top. So 14 pi over 7, and that's going to get you that same value. Okay, and so same deal here. We just added the 24 pi over 12 or subtracted the 24 pi over 12, and I could find coterminal angles to those particular points. Okay, and again, there are lots of correct answers for any coterminal angles. So again, when you graph, I always put the 0 and pi on. No matter what I'm doing, I'm going to put my 0 and my pi. And then if I look and I see what one of my denominators is, so for instance, on this one, it's 5, I always will rewrite in terms of 5. So I just put 5 pi over 5. That's equal to 1 pi. 5 pi over 5 is just equal to 1 pi. So then I can kind of orient myself based on that 180. And so on this one, it was negative. So I did have to make a negative. And all that means is I'm going to flip it around backwards instead of going up and around clockwise, counterclockwise. So for this one, again, you'll figure out what quadrant it lands in. This one happens to be in 3. And then you figure out what the reference angle is by saying how far away is this angle from the nearest x-axis. And so in this case, it was from 13 up to 15. Again, you can ignore the negatives. So from 13 to 15, that's 2 pi over 5. That is less than 90 degrees. It's positive. Great, we got it. Okay, and for the most part, whenever you're finding an exact value, your reference angles should always be over 3, over 6, or over 4. This one's a little different because they're not pretty, and we're just looking for reference angles. Finally, to convert to degrees, from degrees to radians or radians to degrees, you just use these little formulas. In order to make it into radians, you want to make sure there's a pi in the equation now, right? You want to get the pi to be in the answer. So you're going to put a pi in the top. If you do type this into a calculator, do not put pi in your calculator. Just do 5 times 1 over 180 and then put the pi in at the end. Okay, again, do not put pi in your calculator. It's going to make it ugly. So if you want to put a pi in, you need to put the pi in the top. If you want to cancel your pi and go from radians to degrees, you're going to put pi in the bottom. Remember, at this point, 180 over pi or pi over 180 is just equal to 1. Pi radians is the same thing as 180 degrees. So if I take my radian value, multiply it by fancy form of 1, the pi should cancel out. So if I look right here, my pi is going to cancel out and I'll just be left with numbers. And I'll do 5 times 180 divided by 3, and I'll get a degree value. Okay, so again, that's the formula, quote unquote, in order to convert from radians to degrees or degrees to radians. This is 5.7. The largest portion of the test are exact values. Remember, our exact values are the most important part because it takes all of the little pieces that we've been learning and we put them all together. Okay, so in order to find exact values, these are the steps that we wrote in the video. I tried to color code it. So the first thing you always do is draw your angle in the correct quadrant. So for this particular one, I'm finding the cosine of negative pi over 6. So I'm going to draw the angle negative pi over 6, which was just down there. That one wasn't too bad. Instead of going up and around, you went down and around. Then the next step is going to be to find the reference angle. So the first thing is, this is in radians. So my reference angle is actually pi over 6. It's pi over 6 away from 0. But I'm going to convert that into degrees so then I know what triangle I'm dealing with, either a 30, 60, 90 or a 45, 45, 90. Because now once I draw my right triangle with the x-axis, I can fill in the special right triangle ratios, and I do have to watch for my negatives. However, it makes it a lot easier if I'm in degrees for that. So again, pi over 6 goes with 30. So I'm going to put the across from the 30 is going to be the 1. Then across from the 60 is going to be the root 3, and your hypotenuse is going to be 2. So in this case, because my opposite leg was down, it's negative. You can always think about this little chart when you were learning how to graph plot numbers, I guess, plot ordered pairs. In these cases, though, this one is going to be, it's always your X is your adjacent leg and your Y is your opposite leg. So in this case, your adjacent leg in quadrant 2 would be negative. Your opposite leg should be positive. Your adjacent should be negative and opposite should be negative as well in quadrant 3. And then in 4, your adjacent leg should be positive and your opposite leg should be negative. So if that helps, use it. Okay, once you have your triangle drawn, then you go back to the original problem. It says, I want to find the cosine of this angle. Cosine is adjacent over hypotenuse. So my adjacent leg to my reference angle is root 3. My hypotenuse is 2. And that's my answer. Again, your answers are usually fractions, and they're going to have square roots in them. So you cannot type this in your calculator because you will get an approximate answer, and that's not what they're asking you for. They're asking you for the exact value. Okay, so these two problems work the same way. Again, you graph the angle, find the reference angle, draw out the sides, and then find the trig ratio using that reference angle. Some tips for you. Pi never, ever, ever, ever goes on the legs of the triangles. Okay, this right here is saying find me the ratio with this angle. You're not doing anything with the 3 pi over 4. This is like saying this is 135 degrees. What's the sine of 135 degrees? You wouldn't put that on the side. Okay, it's not asking you to convert this angle measure into a degree measure, because what I want is I want to know the exact value, the ratio. If you see sine, cotangent, cosine, whatever, any of these trig functions, they're going to want like a fraction number answer. Okay, your calculator won't help you. That's what I said before. You're going to get an approximate answer. And if you're trying to use the OIO chart and the angle's not on it, then you're going to have to draw a triangle. Sorry. So speaking of the OIO chart, this again will tell you how to find those quadrant border angles in order to find the exact values of them. So you use your acronym to fill out, go SOHCAHTOA across the top, and then your angles always start at 0. So it starts 0, then 90, then 180, then 270. And I use the radian values here because this problem was in radians. And then you can just use it. So if you want to find the cosine of 2 pi, well, 2 pi is coterminal to 0. The cosine of 0 is just 1. Okay. You can also use the fact with the unit circle. I know we haven't gotten to that yet on this video, but with the unit circle, that you know that the x value of that point is 1 and cosine goes with x. So again, you can always draw your little circle out and say, okay, well, if I'm here and this is cotangent, that's x over y, and you can find those pieces. When you're looking at this OIO chart and you want to figure out for the reciprocal values, so for cotangent, secant, or cosecant, you can either do 1 over the value that you're looking for. So in this case, you do 1 over cosine of 3 pi over 2. It's 1 over 0. That gives you an undefined. Or just remember, for the reciprocal values, O's turn to U's, U's turn to O's, and 1's get to stay 1's. Okay. Again, that's just, you can always do this piece if it's easier for you. And then we have problems like this, where they're going to ask you to take your exact values and kind of manipulate them into algebraic equations. Again, the whole point here is that you're looking for this piece. You want to find the cosine of 5 pi over 3, and you want to find the sine of negative 5 pi over 4. So you're going to do those pieces individually, then find what your answer is, and then plug it back in. So don't worry about that 4. Don't worry about that square until you've actually taken those values and figured out what the exact values are. So in this case, the cosine of 5 pi over 3 was 1/2, so I could plug it in for this entire expression. I could plug in 1/2. I found the sine of negative 5 pi over 4. That was negative 1 over the square root of 2. So I plugged that entire thing in, and then I could square. And then you do some math there. But again, these types of problems, they look intimidating, but they're really just asking you to take step by step, figure out what the exact value is, and then use that knowledge in an equation type form. So the last topic we covered was the unit circle. And in the unit circle, again, we derived that unit circle using our reference angles, using the fact that sine of theta is going to be the y-coordinate of the unit circle, cosine of the angle is going to be your x-coordinate, and tangent is like your slope, so it's going to be y over x. So of course you can manipulate that if you need to find your reciprocal values. Again, you don't have to know this unit circle. I don't have this thing memorized. I would write it down every single time. I guess the only piece I have memorized is that I know that this is 1, 0, 0, 1, -1, 0, and 0, -1. So please don't feel like you need to memorize this in order to pick out values off of it. You just need to know that your sine is your y, your cosine is your x, and your tangent is your y over x. So when they ask you what radian value is associated with some coordinates, it's pretty straightforward if you know those facts, because I know for this guy, it's going to be a cosine goes with the x value, sine goes with the y value. So if I draw that point out, it's in quadrant 3. Okay, and then the cosine is the adjacent, so my adjacent over my adjacent over my hypotenuse, and then I could fill in my last side, and I would know this is a 30, 60, 90. Opposite the 1 should be 30, so it's a pi over 6, and then I just have to orient it in the correct quadrant. Okay, again, I didn't memorize anything for that. I drew it out. And the other part of the unit circle that's super helpful is to remember the all students take calculus, or whichever acronym you feel is better. These tell you where your each of your trig ratios are positive. Okay, so for this, everything is positive in quadrant 1. Sine and its reciprocal are positive in quadrant 2. Tangent and its reciprocal are positive in quadrant 3. And cosine and its reciprocal are positive in quadrant 4. So all that means is that if they gave you something like this, where it says if sine's positive, where's the angle? Well, I know that it has to either be in 1, where everything's positive, or in 2, where sine is positive, because that's where the opposite leg is going to be positive. They can also give you stuff like this, where they're like, well, if secant is negative, remember secant is the same, or reciprocal, it'll have the same sign as cosine, and then tangent is positive. Where is this thing? So if cosine's negative, then I can't have it in quadrant 1 or 4. And if tangent has to be positive, so it's got to be down here in the quadrant 3. So that's kind of how that little mnemonic device helps us figure out where an angle could be in the quadrants. The last piece I have are some miscellaneous facts that fit within the unit, but weirdly. So this first one is whenever they give you a point and they say, here's a terminal side, it passes through this angle, find the value of the 6 trig functions. So this is testing you if you know what a right triangle is, if you know where to put the reference angles, and then what the trig ratios represent. So you're always going to plot this point. Take this point, put it on a coordinate plane, -5, 12. Remember, you're always, always, always going to draw your reference angle down to the origin. So this terminal side is going to go down to the origin. Your reference angle is going to be here with the x-axis. I know that the distance from x is -5 because that's the x coordinate, and the distance for y is 12. So now I have my like a picture that I could find using my Pythagorean theorem, or knowing my Pythagorean triples, that this hypotenuse would be 13. Remember, your hypotenuse is always positive. And now I can find those trig ratios. So I can do my SOHCAHTOA or my CHO-SHA-COW and figure that out. Make sure you don't forget your negatives when you're plotting these, because you will get the answer incorrect if it's not negative. But again, it's kind of applying all of the knowledge from the other parts. This is another one of the ones where you're going to need to use your all students take calculus, because they've told you that sine is negative. It's a -7/8, and that secant is positive, so cosine would be positive. So the first thing I have to do is orient myself, find where my angle goes, and then I can draw the triangle and find the missing sides in order to find what they're looking for here. So for this one, since I knew sine was negative, it has to be in 3 or 4, and cosine was positive, that makes the angle have to be in quadrant 4. So I drew that in. Now I know the sine is -7/8. So the opposite over the hypotenuse was 7/8. Your hypotenuse is never, ever negative. So that makes this opposite leg negative, which makes sense based on the picture. And then your hypotenuse would be 8. Now you're going to do the Pythagorean theorem to find that missing leg. Again, the negatives end up canceling out. So now I know that my adjacent leg is √15. So to find cotangent, I just needed to know my adjacent leg over my opposite leg, so I could get √15 over -7. I don't know why I'm doing roots or negative. Okay, same deal here. It's just this one, they already told you what quadrant you terminated in. And again, your hypotenuse is never negative. So if you ever have a negative in one of these expressions, it's just going to automatically go with that leg. So for this case, the adjacent leg ended up being negative. Your hypotenuse is always a positive value. This last question, it really helps to think of your unit circle where your radius is equal to 1. Okay, so if you're thinking on your unit circle, what is the greatest possible cosine value? Well, looking at my unit circle, cosine goes with x. So the biggest value that x can take is right here, and that x value is just 1. So the biggest possible cosine value is just 1. What's the greatest possible sine value? Well, same deal. Sine is y. It goes all the way up to the top of the circle. That's just 1. Oops. So the most negative value would be -1. So again, the biggest value for cosine is 1. The biggest value for sine is 1. So they ask, is it possible for cosine of an angle to be equal to 0.910, blah, blah, blah? Well, sure. That value is less than 1. Why not? It could totally equal that. That cosine value, again, would be over here somewhere. It's not a pretty value on my unit circle, but hey, cool. Now, is it possible for sine x plus cosine x to be 5? Well, the biggest value for sine is 1, and the biggest value for cosine is 1. So the greatest value it could possibly be would be 2. So 5 wouldn't make sense for that one. Then they ask, is it possible for secant of x equals 5/9? Well, you could look at the unit circle for this one. I don't really want to deal with the 1/x business, so draw yourself a triangle. If you draw, this is just a random triangle, a random right triangle, and I know that secant is going to be the hypotenuse over the adjacent. So the top number is 5, the adjacent number is 9, and I look at this, and I'm like, but that doesn't make any sense. Okay, your hypotenuse should always be the longest side. So no, you can't have a secant value that's technically less than 1 or a cosecant value because we're looking at the ratio of a leg to a hypotenuse, and we know that the hypotenuse is always the biggest side. Okay, I hope that helped. If you have any further questions, remember you have this whole review. It's very lengthy, so do what you feel like you need for practice in here. You can always redo some of your My Math Lab assignments, and of course your quiz is a very good resource as well. I think I've actually gone through most of these problems. I'm like, I recognize all of this. Again, this question is just asking you what's x, y. Well, it's cosine, sine. Here's how to find exact values. And then that last page goes into some of the trickier ones where you actually have to find the pieces and then plug them back into an expression to get a numerical answer. Okay. Good luck.